Welcome everyone. Today we are learning about our second shape in our quadratic relations or conic sections unit. This shape is called an ellipse. An ellipse is more commonly referred to as an oval. So kind of like a circle, but stretched out in one of the directions or squished in one of the directions. If we think about how we ended our circle video, we were looking at the equation of quadratic relations, ax squared plus bxy plus cy squared plus dx plus ey plus f equals 0. We said that if a and c are equal, then we end up with a circle. If a is not equal to c, then we might run into an equation that is an ellipse. So an example of an ellipse or an equation of ellipse would be 9x squared plus 25y squared equals 225. So here we can see 9 and 25 are not the same or not equal. So this will be not a circle, but an ellipse. For ellipses, just the plural of ellipse, we are going to go over some key vocabulary words of how we can describe ellipses. So below I have an example of an ellipse or an oval. When describing ellipses, because we don't have one fixed radius, we are going to be describing it in the two directions. So the vertical and horizontal directions. So to start off, the direction here, in other words, the longer part of our ellipse, is what we call the major axis. So two axes, the major axis, which is the longer part of the ellipse. We also have the minor axis. So the shorter axis is the minor axis. So we're describing our ellipse using two different axes. The longer one is the major, the shorter one is the minor. Instead of saying major and minor axes, we can be a little bit more specific and talk about ellipses in terms of their radius. So our radius is connected with our axes, but our radius has to do with the distance from that center to the point on our ellipse in either direction. So in this case, when it comes to radius or radii, which is plural for radius, we are talking about them not in terms of which one is longer or shorter, but just the directions, which one is going left and right, which one is going up and down. So for example, the x direction is just going to be our x radius. So our x radius is just this distance here. And then the distance from the center to the point on the ellipse in the y direction is the y radius. So because we don't have a fixed radius, we're going to be describing our ellipse in terms of the x radius and the y radius. Radius still has the same meaning as a circle, where it's the distance from our center to a point on our ellipse. So we'll talk more about the equations for ellipses or an ellipse in another video, and we're going to learn a little bit more about how we can change these equations around and identify key parts of our graph using the equation. For this video, we're going to look more at the, we're just introducing the ellipse, and then we're going to look at the geometric definition also. Okay, so I'm going to add in some pictures quick. So here we have probably the best ellipse I'm going to draw. Not great at drawing ellipses. To start off, for our geometric definition, we're looking at 2 points inside of our ellipse. And each point is called a focus, which the plural for focus is foci. So each point is a focus. So I'm going to label these F1, our first focus, and F2, our second focus. We're going to be looking at points on our ellipse. So again, an ellipse is just a set of all of the points on our ellipse or our oval. And we're looking at the two distances between our point and each focus. So we could call this D1, and we could call this distance D2. So we're looking at the two distances between our point and our foci. For the geometric definition of an ellipse is a set of points in a plane where for each point, the sum of the distances or its distances in other words, D1 plus D2 from two fixed points, F1 and F2, is constant. So when we add up these two distances, that sum is going to be the same for any point on our ellipse. For example, if we were to put another point down here, and we looked at the distances D1 and D2 between that point and the two foci, here D1 plus D2 is going to give you the same value as the two distances or the sum of the two distances that we see in our other point. And that's true for any point on our ellipse. So we could do it here and we would end up with the same sum. So we can see this definition, geometric definition of an ellipse, a little bit more clearly through an interactive graph. So scrolling down a bit here, you can see we have an ellipse, an oval shape. We have a point P on that ellipse. And then we have two distances, the distance here between P and our first focus point, and our distance here between P and the second focus. And each focus, where it's located, where these two foci are located, define the ellipse that we're looking at. So we're given, for example, these foci, and then we can find the ellipse that emerges from those using this definition. So up here, you can see the distance between our point and our first focus, the distance between our point and our second focus, and then the sum of these two distances. So for example, now we have 11.1 here, 4.9 here, and their sum is 16. If we move this point around our ellipse, no matter where we put it, for example, here we have a distance of 8 between each of them, our sum is still going to be 16. And that's true no matter where we put our point. So even if we put it down here, we still end up with a sum of 16. So an interesting interactive graph of an ellipse. And I'll add the link in the description too, so you can take a look at this website. All right, finally, we'll look at the equation of ellipse a little bit more in our next video. For this video, though, I just want to finally talk about the conic section definition for an ellipse. So this entire unit is conic sections. All of our shapes can be found by cutting into a cone. Here we start off with a cone. We then in step 2 cut the cone, and we're cutting the cone at an angle. So as you can see here from the side view, we're cutting the cone at an angle, so it's not horizontal like we did with the circle. And another quick note, our angle just shouldn't be parallel to one of the sides, and we're not going to do an angle that's extreme. So for example, cutting through this bottom part of our cone. So just an angle, for example, here, a steeper angle would work, or an angle, as long as it's not horizontal, would work. So we're cutting through our cone at an angle. And you can see the orange part is kind of like the cross section here. In step 3, I've taken the two pieces apart so you can kind of see this cross section. And the cross section that we end up with when we cut through the cone at an angle is an ellipse. So that kind of like elongated circle. So our conic section definition of an ellipse can be found through cutting a cone at an angle.